Let's take a look at solving simultaneous equations, this time by elimination. Now, as I've said in the previous videos, um, the elimination method is by far the more popular one, especially at National 5 level, because it doesn't involve as much algebra to allow us to eliminate one of the variables. And remember, that's a key thing for solving simultaneous equations. We have to make sure that we eliminate one of the variables to then go and solve for the first variable and then substitute in to get the second variable. So this time we're going to look at the same equations that we had in the first substitution method. So we've got, this time I've adjusted it to say y minus x equals minus 3. So I've changed it from y is equal to x minus 3, and I've moved the x across to make it say y minus x. Because when we use a simultaneous equation, solving it by elimination methods, we put them into a strict format of variable plus or minus variable is equal to number. So to allow us to solve these equations, I've put that into that format. So we've got y minus x is equal to minus 3 and y plus x is equal to 5. What we then do is, to allow us to solve these, you want to eliminate the variables. And you eliminate the variables either by adding or subtracting the two equations together. To allow this to happen, what you want is to have the same number, the same digit of variable. So for example, here we have y minus 1x is equal to minus 3. And we have y plus 1x is equal to 5. So I've got a minus 1 on that equation, and I've got a 1 on that equation. If I was to then add these two equations together, minus 1, if you add 1 to minus 1, they cancel each other out, it becomes 0. So if I've got minus 1x and plus 1x, if I add minus 1x and plus 1x together, it just becomes 0. So I can forget all about x and just focus on the y. But because I'm adding the two equations together, it means that I add my y's, I add my x's, and I also add my numbers. So here, if I say y plus y, if I bring these together, it gives me 2y. The minus x and the plus x cancel out. Then I've got minus 3 plus 5, which adds to give me 2. So therefore 2y is equal to 2, so y has to be 1. Then all I do is I substitute in y is equal to 1 into equation 1. Okay, so substitute y is equal to 1 into equation 1, or I could put it into equation 2 as well, it doesn't really matter. Substitute y into the equation, so it gives me x is equal to 4. So therefore the solution is going to be x is 4, y is 1. So let's look at some examples and we will work through that then. Just ignore this bit here. I don't know why that's there. That confuses me. Even just scrub that out. Must be a misprint. Right, let's look at the first example. Right, example 4a. So I've got x plus y is equal to 5 and x minus y is equal to 1. What you will probably notice here is that I will usually tend to go for the variable that's in the middle, so the one that's closest to the equals. That's purely the way that I was taught to do simultaneous equations, and I will usually tend to manipulate it to make it go like that. You'll probably end up doing the same thing as well. So here I've got x plus 1y is equal to 5, and I have x minus 1y is equal to 1. So if I've got a plus and a minus of the same number, if I was to add these two equations together, I can eliminate them. So if I've got x plus y is equal to 5 and x minus y is equal to 1, if I add those two equations together, treat it like one great big sum, it's going to be x plus x, which is 2x, 1y plus minus 1y, they cancel out. 5 plus 1 gives us 6. So if 2x is equal to 6, x has to be 3. And then substitute into any equation. So we'll say when x equals 3, so it doesn't matter which equation you sub it into. Let's use the equation x plus y equals 5. So let's sub 3 in for x here. So I get 3 plus y equals 5. So y has to be 2. So therefore x is equal to 3 and y is equal to 2. Remember, equations, when you solve them, they're always self-checking. So you can always check that you've got the right solution here by substituting your answers into the equations. So if x is 3 and y is 2, the first equation was x plus y is 5. Well, 3 plus 2 is 5. The second equation was x minus y is equal to 1. So 3 minus 2 equals 1. The next example here has 4x minus y is equal to 20 and 3x minus y is equal to 17. So, to allow us to solve these equations, what you'll notice here is that I've got a minus y, a minus 1y, and a minus 1y in the second equation. In the other equation we had a plus 1y and a minus 1y. If I added them together, I would have got 0, but if I add minus 1 and minus 1, if I say minus 1 plus minus 1, that would give me minus 2. That will not eliminate the y's. So, if I've got the exact same sign of number, i.e. I've got a minus 1 and another minus 1, I don't add them to eliminate, I would have to subtract them to eliminate. So this time I'm going to subtract my simultaneous equations. So it's going to be 4x take away 3x, treat it like one great big sum. 4x take away 3x gives us x. Minus 1 minus minus 1 cancels out, so it just becomes 0. So therefore 20 take away 17 gives us 3. So when x is 3, substitute into any equation. Again, doesn't matter which equation you use. Let's just use the top equation again. So when x is 3, we have 4x minus y is equal to 20. So it's going to be 4 times 3 minus y equals 20. So it's going to be 12 minus y is 20. So therefore, y has to be minus 8. So final solution, final answer is going to be, therefore, x is equal to 3, y is equal to minus 8. And that's it. We're going to go through a lot of the same type of example here, and there will be subtle differences as we go through it. But this next diagram really shows you the best way to approach simultaneous equations. So in that example there, we saw that the elimination method can sometimes be done either by adding or subtracting the equations. However, most often only one option will be appropriate, and it'll be up to you to decide what is the appropriate method to use. And sometimes if you use the wrong method, it's because you've chosen to either subtract or add the equations when you should either be adding or subtracting them. You get it confused. So I hope this chart is able to help you in this way. So when you're dealing with the elimination methods, have a look and look at the variable you want to eliminate. So back in this, we were eliminating the y's in both equations. So we were eliminating the y's here. In the first example, 4a, we had plus y and minus y. So it says here, look at the variables. We want to deal with the y's. Do they have the same sign? No, they don't. So if they don't have the same sign, because one was a plus and a minus, then we add them together. The second example, wrong way. The second example had a minus y and a minus y together. That is the same sign. It would also work if it was a plus y and a plus y. This is a minus y and a minus y. So if it's the same sign, in order to eliminate those variables, it's the same sign this time, so therefore we're going to subtract. I usually just remember this as being same sign subtract. So if you have a plus plus, it means subtract the equations. If it's a minus minus, it also means subtract the equations. If you get a plus and a minus, just add them. That's it.